Okay, so starting this video, this is going to be about the 2019 AS paper. It is going to be pure paper one. These are the mistakes I've done. This is the one I'm going to do. Let's get started. Okay, so this question starts off. Sketch C stating the equation of the horizontal asymptote. Horizontal asymptote basically means the asymptote where it's like that. This is the horizontal, and you got the curve like that, and this is where the asymptote is kind of the two regions that kind of separate the thing. I'll show you what I mean. Okay, so we're given this equation: y equals k squared over x plus 1. Okay, and I'm moving a bit quick here so I can get the video nice and edited, not too long. It takes ages to export. Okay, so generally a graph like that would be like this. Okay, this would be the x coordinate, y coordinate, and generally it would be like this. Unless the bottom is squared. If the bottom is squared, it would be like this, but it's not. So the bottom is the normal x. It doesn't matter if the top is squared or not. If it's a million, if it's 1, if it's anything else, it doesn't matter. Okay, the whole point is that the x is the normal x. As long as the x does not change, this graph will stay the same. Okay, it's generally the same shape. Okay, so it's going to be around like this. And now it's asking us for the horizontal asymptote. So it says sketch C stating the equation of the horizontal asymptote. So this is a sketch of C. Okay, now it's plus 1, so we elevate it 1, it's not with the x. This should be like a rule that we all should know. So when we move it up 1, it's going to hit the y coordinate. Okay. That's a bit too short. Alright. So it should be like this, but not that diagonally off. Slightly more straight. Okay. And now we have to know the equation of the horizontal asymptote. That's quite easy. What you would do is you make the x equal to 0. So y equals k squared over x plus 1. If you make x 0, then k squared divided by x would be 0. Y equals 1. And this this would be the asymptote. This would be y equals 1. So the asymptote, I never know how to spell this one, would be 1. Okay. Pretty simple things here. Alright. This is part A. Now we're moving to part B, if I am not mistaken. Okay. Show the x-coordinate of any point of the intersection of L and C is given by the in the solution of the equation 2x squared minus 4x plus k squared. So okay, we're given another line. So this is our first line, so I'll call this L1, and L2 would be y equals minus 2x. Y equals minus 2x. What was it? Plus 5? Plus 5. Okay, and now it's telling us it will equal an equation being 2x squared minus 4x plus k squared. Okay, and how we would solve that is we will do simultaneous equations. So we will make them equal to each other. Y equals y is a type of simultaneous equation. So we would make them equal to each other. So y squared, that's k squared over x plus 1 equals minus 2x plus 5. Okay, tidy this bad boy up. K squared over x equals minus 2x plus 4. Okay, times everything by x to this side, because if it's divide, we want to times them all by x. K squared equals minus 2x squared plus 4x. And then it wants it at a specific kind of way, so we can't have them or x going to that way. we can't have, because it wants us k squared to be positive, so we want to make this positive. By keeping this positive, we move things over here instead of moving that over here. So k squared will stay the same. So k squared plus 2x squared minus 4x equals 0, and that would be correct. Okay, next question. Okay, says okay, let me just rub this out. It says, hence find the exact values of k for which L is a tangent of C. Okay, exact values of k. So we want to find out what k is. We've gotten the, so if we put down what we got previously, because for some reason maths always just works on the things you got previously. So this would be 2x squared minus 4x plus k squared equals 0. We want to find out the values of k, and so to do that we have to do discriminant. The discriminant would only work on values that are quadratic. So we do b squared minus 4ac minus 4ac. So we would have to find out the values of a, b, and c. This would be a, this would be b, and this would be c. So that would be 2, that would be minus 4, and that would be k squared. Now we organized each section, substituting it to the equation. So that would be minus 4 squared minus 4ac okay, so it'll be 16 minus 8k squared equal, so that would be equal to 0. Finally, we move 16 to over here, dividing each side by minus 8, giving us k squared equals 2. Square rooting each side would give us k equals plus or minus 2. So that, ladies and gentlemen, would be the value of k. Alright, starting off to the next question. Okay, so we're gonna start off with this question. I was a little confused, but then looking back at it, it makes a much more sense now. So you know how in part A we were told that we were given the equation and it equals to 4 minus 5 cosine theta. Okay, and then it says hence or otherwise, so for 0 greater than or equal to x 360, we're given this, and we're trying to solve what x is, okay? And then we're given this, 10 sine squared theta. And instead of theta, it will be x, but it's still relatively the same, because theta is an unknown and x is an unknown, so it's pretty much the same unless they're both in an equation. Then that would make them not the same in the same equation. All over 3 minus, well actually 2 plus 3 plus 2 cosine x equals 4 plus 3 sine x. Okay, so you know how in the previous question we managed to get this as being 4 minus 5 cosine? So 4 minus 5 cosine, well, theta, but it was x in this point, equal to 4 plus 3 sine x. So you see, this and that is the same thing. Same thing, right? And then we're equaling it to that. So now we just tidy it up. Okay? the way we would do that is by turning it into tan. Okay, so the way we do tans is it's sine over cosine. It's not cosine, so not cosine on top and then sine. It's sine on top and then cosine. That's how tans work, and it's just applying that rule. So first things first, get them out of the way. So 4 minus 4 would be 0, so that cancels out. Okay, and now we do, okay, hold on. We do divide that by cosine x, divided by cosine x. We get minus 5 equals 3 tan x, and then divide that by 3, and we should get minus, and we should get 3 over here as tan x. Minus 5 over 3. Yep, I'm just going to quickly rearrange it. So it's going to be tan x equals minus 5 over 3. So that should be that. Okay. Same thing, just rearranged kind of. Okay, and so we're left with this. Okay, and how we would work out x in this scenario, we just bring this bad boy onto the top. So tan x equals minus 5 over 3 is we would do the inverse tan. Okay, so the inverse tan of this, so it would look like this: tan minus 1 minus 5 over 3. The inverse tan of this would get us x as being equal to x being equal to minus 59. And by the way, when it comes to things like these, you obviously have to watch out for things like decimal points, but in this scenario it's not really telling us. Okay, minus 59, and then with tan, there's a specific rule for every subset of things. So tan, cosine, and sine, they will be different on how you would find out x. So in tan, for example, instead of like cosine where we do 360 minus x, tan is plus 180, and this is just something you have to remember. And then sine, I believe it's 180 minus x. So this, in this scenario, this would be 180 plus x. So we're given x. Now, when we do this, we make sure that if it doesn't fit this, then we just cross it out. Just to let the examiners know that this is not a part of our answer, these will be. Okay, so that will be 1, 2, 1. Okay, and then for the next one, instead of doing 180 minus x again, we will add 360. So plus 360 to the original answer, giving us 301.0. Or 301 because it didn't ask for any decimal places. And that will be our answers. So these two will be equal to x in this range. And that is your answer. Okay guys, so hopping on to the last question. We are doing question 16. That would be the last question. Okay, so I've been analysing this for a couple minutes, and I still kind of am confused, not to the extent I was when I first started the thing, but I'm still slightly confused. But I think if we go on to it, it will become a little easier. So we're given two non-zero vectors a, b, such that a, oh god, I keep using the purple, man. A plus b equals a plus b. Okay, these lines generally tend to signify magnitude. So explain geometrically the significance of the statement, and the answer would be a plus b must be in the same direction. So A plus B must be in the same direction. I don't understand how that works, but I'll try to look into it. I'll probably put it in the comments, maybe something like that. But it's part 2 that's quite doable. So this is the only part that's kind of confusing me. Okay. Right. So two different vectors, m and n, are such that m equals 3 and m minus n equals 6. The angle between vector m and vector n is 30. Find the angle between vector m and vector m minus n. Given your answer in degrees into 1 decimal place. So, we're given m equals 6. M minus n equals... No, sorry, m equals 3. M minus n equals 6. And we have n, which we don't know about, but we'll just put n. I believe n would be... Yeah, so that's right. Okay, then we just form a triangle, right? Okay, so we got m minus n, and n. Okay, we don't really need to work out what n is. We just know that it told us that the angle between vector m and n is 30. So we've got m and n, and it's the angle between them. So this would be 30. Okay? Next, what we would do to find the vector between m and n, m minus and vector m minus n, is we would find out what. So this is basically asking what this is. Call that x. So the vector between m and m minus n. So m and m minus n is there. This between them is what we need to find out. Okay? Right. So, next thing we do. By the way, because they are vectors, one is going up. One is going up like that. One is going up like that. Okay? So, to find out how to do this, we must apply the sine rule. And that being, we have to find out, first of all, what this would be. So if I just add in what these are, this would be 6. I'll call this guy y. Okay, so we apply the sine rule to find out this, because so we do the sine rule to find out this. We do 180 minus 30 minus y, which we will find out, and then we will find out x through that. Okay, so sine rule states, so we are trying to find an angle, so the sine will be on top. So sine y is over 3 equal to sine 30 over 6. Okay? Work out what this is and then times that by 3. So work out what this is and then times that by 3. So you just pretty much do this. We would get, so that would give us sine y equal to 1 over 4. And then we do the inverse sine of this. So inverse sine, so we would do inverse sine of this, which would give us 14.5. Okay? Right. So we now found out what y is, which is 14.5. And we do the angles in a triangle would be 180 minus 30 minus 14.5, which should give us 135.5 to 1 decimal place. And that, ladies and gentlemen, would have scored me 17 marks, giving me 91. Unfortunately, I didn't get that. But you can see it's quite simple. Things you already know, you just build on them. But yeah, it was quite difficult for me, even discussing this, considering the fact that I already seen the answers and everything. So yeah, I mean, good luck on the 2019 paper.